There we go. Yeah, we're just missing just like three people here, it looks like. So we'll go ahead and get started. Maybe they'll join in or they'll have to watch the video later, however that works. But we'll put up our screen and take a look. This is the math module this week. So that's why we didn't do this last week because we didn't meet till Friday. And a lot of you guys didn't have to be here Friday since you watched the video last Friday. Foundations of Programming, right here. Let's go to our grade screen. Let's see. So last week we had the special assignment I made the video about, gave you a special programming assignment, just a small program just to keep you in the practice, get you ready for this week, which is the math module. So we have the math module, the next week, the software development lifecycle. So let's look at the math module. Well, can't look at the assignment yet. Let's go to the other screen. All right, the math module lesson. We're going to actually do some math in our program this week. This is a little more complicated program, so you may want to take notes or make sure you're going through this in Buzz together, doing the practice stuff in Buzz on their program. So, what's better than a snuggly new puppy? It's easy. A pre-trained puppy, yeah, because you get puppies, they chew up everything, they use the bathroom in the house, all kinds of crazy stuff. You don't have to teach him to sit, roll over, or not eat your shoes if he's pre-trained. See, if only life was that easy. Well, Python is that easy. Well, maybe. It's time to explore what this programming language has to offer. It's a little more advanced than having your puppy roll over. So we're going to, in this lesson, use the math module to identify useful black box functions that are built into Python. We're going to identify the types of operations that can be performed with numeric data and mathematical expressions. We're going to research functions related to Python using different sources to use for creating programs. And we're going to use the power and the square root functions to answer mathematical problems and write a program. So we're adding some mathematical functions to our knowledge bank this week. So if you haven't already guessed, Python has a library of built-in functions to make programming work easier. These are sometimes called black box functions, because the code's hidden, like print, string, integer, float. Those are things that were already built in there. We just had to learn the command. So there's a reason they do what they do. Other programmers wrote those functions into Python. So just pick one to use in your code, and Python does all the work. So this way, you're totally impressed, and Python feels really special. Ta-da! To set the record straight, Python's not performing magic tricks. It's just doing the hard stuff, so you don't have to think about it. You just use the command, and Python does all that stuff. So something useful in Python is its math module. It's a collection of pre-built math functions that prevents you from having to math the problems out yourself. Just tell it to do the stuff. So let's say you want to take the square root of something. When can you do that in your head? Well, on some numbers you can if it's a perfect square, right? But if you're taking like the square root of 21, well, that's going to be a little trickier. So do you want to do that on paper? No, not really. So here's the good news. Python can do it using one of the functions in the math module. So to use these functions, we have to tell the computer where to find them. So we're going to have to add this at the beginning of our programs again. From math import asterisk. And that tells Python, hey, I want to use those cool math functions you got built in. So go get those and load those up and be ready to use them. All right, so the math module has a ton of math functions available. And look, they provide them for us right here. So if we click this link, Python API, here is a link showing a ton of functions that Python has available. All right, built-in functions. Append. These are in alphabetical order. BIN, that's using a binary. That's taking a decimal, making it a binary. CHR, that converts a number to its corresponding ASCII value. Float, we've talked about float. Hex, if we want to convert it to a hexadecimal number. Input, we've used that one. INT, we've used that one now. LEN, we'll be using that some this semester. Length or this year, the length of something. Max, that looks at a list and turns the maximum value in. See, this gives example on how to use all these things too. So you can start playing with this. You might want to save this off or something, so you don't have to go back to this lesson and look at it every time. There's a min, brings a minimum value from a list. ORD, it converts a one character string to its ASCII value. And we will do some of this too. Range, it returns a progression of integers from 0 to 1 less than whatever to stop. Range, start and stop. Range, start, stop, step. There's that string. We've used string function. Here's some math module. Here's the math module part. ABS, that will return the absolute value of a number. Brings the cosine. It's got cosine built in there. Power, we're going to use power. That returns like 4 raised to the power of 2.3. If we did 4 squared, we would use the power function where we put a 4 and then we put a 2 as the exponent. It would bring back a 16. Right? And this returns a floating point number, by the way. Power does, unless you tell it it's an integer, which it shouldn't be, because it's not always an integer if it depends on your exponent. Radians, getting into geometry where it's measured in degrees, you want to convert it to radians. There's the sine function. There's the square root. If you want to find the square root of a number, there's the command, square root number. RAID it. This is returns a pseudo random integer within a specific. So this is random integer. So if you want it to, and by the way, computers are terrible at random numbers. They are absolutely terrible at random numbers. They cannot generate random numbers. They have a built-in function to make pseudo-random. That's why it says pseudo-random. It's not really random because the computer calculates a random number. And it does it in a lot of different ways. Depends on the program, depends on the computers. Some of them look at the clock and use the clock as a starting point to generate a random number. So that way, every time you ask for a random number, it's different because the clock has a different second that it's starting with. So it struggles to really come up with random numbers. Here's just random. The random function returns a pseudo-random decimal number greater than 0 and less than 1. So that would be a number between 0 and 1. Turtle, we're going to use the turtle graphics. So turtle function, here's details in that. Backwards, begin fill, circle. It makes a circle like that. Circle with a certain radius and arc degrees. Color, infill. You can have a lot of fun with the turtle. We'll be doing that very shortly here. I think we'll do that before the semester's out. Hide turtle. Left. Tell the turtle to turn left. Put the pen down. Here's the size of the pen. Bring the pen up. There's all kinds of stuff we're going to be playing with. So anyway. Turtle has a lot of functions you can play with in here, but we will get back to that. So I think I'm gonna go ahead and print this as a PDF. I may put this in our Google Classroom so we have this. Let's just save that as a PDF, and we'll save this as Python functions. So I'll put this in our Google Classroom here shortly. Save that off. Python function. Python commands probably be better. But we have more identify what it is. All right, so that is there right here in our lesson, the Python API, right there on page 2. So take a look and get familiar with some of the different functions. So while there's many more they can use for a variety of mathematical processes as you advance with your program, today we'll just start with some basics. Like finding the square root. So using the Python math module, which function would be useful in that? Square root. Well, it would be the sqrt command. Square root with parentheses, whatever number you put inside the parentheses there, it's going to give you the square root of that. Raising x to the power of y. So when we use this power, we put the power, we'll put x comma y in there, and it would make x raised to the power of y. All right, let's look at page 3 here. Using power and square root. So this is what we're going to focus on this week. Once we've imported the math module, remember we got to use that math import statement there. You have access to all the functions in the math module. So all you have to do is call up the function and then provide any related arguments, which is a value provided when the function is called. Two of the most common are the power and square root. So here's power. Oops. Look, they used it like a video game here. You guys, I finally found the magic axe of Cardassia. Time to level up like a boss. So I need to get 5 experience points to upgrade it. So power function. Okay, we're going to help this gamer figure things out by using Python. Although we think the armor looks fine just like it is. Okay. The magic axe of Cardassia lets you gain levels exponentially faster than before. So gamer, here's his gamer name, G4 Men Forever. Did that just happen? I see that mute button's on. Has it been on long?
No, sir.
Okay. It turned itself on for some reason. That's really weird. So thank you. All right. So his magic axe that he has, instead of gaining experience at 100 points per battle, now with this magic axe, it has 100 to the power of 1.2 experience points per battle. So exponentially, you gain more points. So it's trying to figure out how many battles it takes to reach 5,000 experience points. So here's how the power function works. You got to use this function, POW, POW, that tells Python to raise the first number by the value of the second number. So the first number you put in is the number you want to raise to an exponent. Take this number and raise it to an exponent, 100. And here's the exponent. They're going to raise 100 to the power of 1.2. Okay? So it says, looks like our gamer buddies ran into another snag. So read on to see how the math module can come through for the win. Hey, turns out I can't level up in time. What? Why not? Well, I've got finals coming up and like 3 papers to write. So I literally have just tonight to figure out this program or I'll never get to play this game again. So basically, I need the square root of 3. Dude, just use the math module. So square root, here's how square root works. Oh, this is to print the answer. Print the square root, whatever number you put in parentheses, it'll take and give you the square root of 3. So you can do print square root of 3, and it will give you the square root of 3. We don't have to tell it how to calculate that. We don't have to figure out how to take the square root of that. That's one of the built-in math functions that we called up when we activated the math module. So we'll never see how Python performs the math functions. That's because the functions live in the black box, and then Python doesn't bother us with the little details. It's kind of like a calculator. We don't have to know how the calculator comes up with the number. All we do is press the button and it gives us the answer. All right, let's go to the next page and start playing with this. Oh, they want us to know somebody here is the programmer Donald Knuth, or Knuth, probably Knuth. 1938, still alive, up in his 80s. Most likely to grow plants with square roots. A little joke there. Author of The Art of Computer Programming. This programmer is also a math enthusiast. He's a mathematician. He has a soft spot for numbers and writing super complex mathematical algorithms. He is dubbed the father of the analysis algorithms. This guy can run mathematical loops around you and crack jokes while doing it. So here's someone that's really into math and programming. So who knew numbers could be so fun? I did. I knew that. I know. Especially when you write a program to crunch the numbers for you. So by learning and utilizing the functions in Python's math module, plus all of its other built-in functions, you can create some pretty awesome programs. So let's look at the math module right here. It's our turn to write some code with it. So here is our guided activity. So we have our hashtag at the top. All right, here's that statement we have to put before we define our main function. We have to import the math module. From math import asterisk. That tells Python, hey, I'm going to use some of those. I'm going to use some of those math functions. define math, define main. Here's our main function. And we assign two numbers to variables. Here's the variable num, which we made equal to 4, and the variable exp, supposedly for exponent, to 2. And now we tell it the variable p is going to be, here's that math function, power. Take the number to that exponent and set that equal to p. And now we're going to print that number that we put up here at the first one, 4, to the power of 2 is whatever it calculates it to be. So let's run the program. 4 to the power of 2 is 16. See, that's 4 squared using the power function. Pretty neat. So just using the simple function called pow and giving it 2 numeric values, it will return result. So we didn't have to tell Python, well, when you square something, you multiply a number by itself. So you need to multiply 4 times 4. No, we didn't have to tell it that because it knows how to use a power function. All right, let's hit the next button. Square root. So now, again, import our math module, define our main function. Now we took 4, raised it to the second power using the power function again. And then we're taking the square root of num. Num was 4. So we're going to print the same thing we did before. 4 to the power of 2 is 16. But then we're also going to take the square root of 4. And that's the end of the program. So let's run this. Run program. 4 to the power of 2 is 16. The square root of 4 is 2, because 2 times 2 is 4. Notice it doesn't give us plus or minus 2. It only assumes the positive side. But that's all right. Generally, when you're dealing with a program, that's all you want is the positive side, because you're generally dealing with real-world things. And we don't deal with the negative numbers much in real life. If we're taking inventory or doing something like that, we're going to use the positive numbers. But there's an example of how to use the power function and how to use the square root function. All right, let's see what they want us to do now. Read the code, predict the output, run program. Okay, so define main. We've got our math import. We've got our 4. We've got our 2. This time we've got a 4.0. See, back here, we just gave it a 4. Now we're making it a 4.0. And we want to take the square root of the 4 and again take 4 to the power of 2. Print string, whatever 4 is, to the power of string, whatever the 2 is. And string that. Let's run it and see what happens. Oh, it says square root is not defined on line 10. Square root was one of those math module functions, and we did import the math function. But look at this. We put a number sign. We put a hashtag in front of math import. So it ignored that. That made it a comment. So it never imported the math module. So we tried running the square root function without telling Python, hey, I'm going to use those math functions you got built in. So go get those math functions so I can use them. If we put this hashtag in front of it, that's just a comment that Python ignores. So if we delete that, now we've got the math function and it will run again. So we have to have this statement at the beginning of our program before we use any math functions. Before we use any math functions, you have to have that. Don't put a comment in front of it. All right. Now it wants us to modify this program to calculate the distance between X and Y. Distance is the square root of X squared plus Y squared. Oh yeah. So here, let me bring up the camera to say what they're saying. It's like, okay, they're using the distance formula. The distance formula, if you have an X and a Y, the distance formula is the square root of x squared plus y squared. You take the x and square it, the y and square it, add them together, and take the square root of that. That is the distance formula. So that's what they're saying. So when you read that, distance is the square root of x squared plus y squared. They really should put that in parentheses, the x squared plus y squared. Because it's not the square root of x squared. It's the square root of x squared plus y squared. All right, so what have they done here to start? Let's run. Let's see. There's a run. Okay, right now it doesn't even run because we've got a bad input on 13. Oh, because 13 doesn't even have a formula yet. All right, so they gave us an x of 4 and a y of 3. And they want us to find the distance. The distance equals the square root of x squared plus y squared. So we've got to write the program to calculate what the distance is. All right, how are we going to start? What do you think? What are you thinking? How can we do that? Well, let's see. The first thing we need is square root, right? So let's start with that square root function. Everything in those parentheses, we're going to take the square root of. But we've got to square the x and add it to the squared y. So that's what we need in our parentheses. So let's see. The x is right here. It's going to be 4. So we're not going to use the 4 because that could change. We're just going to use x. So if we want to square that, we got to use the power function. Right? So that's going to be there. And then we're going to do plus the power function again. So in the first one, we need to square the x. X, comma, 2. The second one, y, comma, 2. So if we did everything correctly there, and I hope we did, because we're just playing with this now, and it's giving us a hint down there, square root, power plus power. That's what we did. And in the powers, we're taking x and taking it to the second power, because that's how we square it, and y to the second power. So let's see what it comes up with. What should our answer be? It's the square root of x squared plus y squared. 4 squared is 16. 3 squared is 9. If you add those together, that's 25. The square root of 25 should be 5. So if we did it right, the distance should be 5. Let's see. Oh, we did it right. The distance is 5. So these are the things we're learning this week because we're going to use these in our program. We use these functions right here. Square root, and everything inside here is being taken to the square root. Whatever I put in between those two parentheses, I'm taking the square root of. Power squared, y squared, x squared, y squared. All right. Let's look at our program that we have to write. Okay, here's the assignment template. And I should have this in already in our Google Classroom, the template, but let's look at it here. What we have to write. All right, this is you've got a little flexibility in what you do, but it's a little more complicated. There's 3 parts. All right, part 1, write an interactive program to calculate the volume and surface area of a 3-dimensional object. A box, a ball, a planet, some 3-dimensional object. Something that's either a cube or a sphere or a cylinder or a cone. Because they're giving you the formulas for those. So you're creating a word problem that involves calculating the volume and surface area of a 3-dimensional object. Choose one of the following. So you're going to pick what the item is. Let's say it's a cube, all right, which would be a box or a dice or, something that's a cube is 3-dimensional, a desk, something that's a cube. Surface area is 6 times the side squared. How long is one side of a cube? Because a cube is the same dimensions every direction, height, width, length. All of them are the same. Think of a pair of dice. Each one of those dice are a cube. So they're the same length, width, and height. So that S is just how long is one of those sides. How long? What is the length? What is the width? What's the height? Doesn't matter. That's S. So the surface area is 6 times the side squared. The volume of a cube is the side taken to the third power. Length times width times height. So if you choose something that's a cube, there's your formulas. Now a sphere, if you're doing like a basketball or something, or a planet, the surface area formula is right here. 4 times pi times the radius squared. That's the surface area formula. The volume is 4 divided by 3, so it's 4/3. 4/3 times pi times the radius cubed. So that's the volume formula. They're giving you the formulas for surface area and volume. So you don't have to find the formulas. You don't have to make up the formulas. They're right here. You just have to pick which one you're going to use and put in your program. Cylinder. A cylinder, that would be like a can, a glass, a trash can, like those big barrels, trash cans. Anything that's a cylinder shape, if you choose that, 2 times pi times radius squared plus 2 times pi radius times height. So Shreddy says, so the 6 for the cube can be replaced. No, the 6 is not replaced. For the cube, you would replace the S with the actual dimensions of the cube. It stays 6. The 6 does not change. Any of these numbers you see in these formulas, they do not change. Whichever one you use, the numbers do not change. The only thing changes is the variable, like the radius. You got to find out what the radius is of your basketball or your planet or whatever. The side length, you can find the side length of your cube. So anywhere you see an S or an R or an H is the height. Those are the things you actually replace with numbers. So cone, if you choose a cone, like an ice cream, pi times the radius times the radius plus the square root of the height squared plus the radius squared. That's a complicated program, but they gave it to you right there. They gave you the formula. All right, so you're going to print a description of the word problem for the user to read. Hey, this is the surface area and volume of the planet Mars, or whatever you're doing, of a soccer ball, of, a 12-ounce can of Coca-Cola. So this is then ask the user to enter the information necessary. Okay, so this is where you're going to have input statements. So maybe you're going to ask the user, okay, we're going to calculate the surface area and volume of a ball. Enter the radius of the ball. So the input is going to give you your numbers, going to give you your S. The input is going to give you your R. This will calculate the surface area and volume of a planet. Enter the radius of your planet. And that lets the user that's using your program choose which planet they want to do, or choose which balls that they want to know. So, but that means the user would have to enter your S, or enter your radius, or enter your radius and your height. That puts it on the user. Now, anywhere in these formulas, if you use one of the formulas that uses pi, use 3.14. Let's not use pi itself. Use 3.14 in your formula instead of pi. All right, so we're all just going to use the truncated, the rounded value for pi of 3.14. Print the results of each of your calculations. Here is what the surface area is, and print the surface area. Here's what the volume is. Print the volume. All right, and then we've got to write the pseudocode for this program. And in the pseudocode, we're going to list any input, calculations, and outputs. So put in our pseudocode here. So part 2 is actually writing the code. After we write our plan, we're going to use Python and write our code. Make sure this is for every program. We always have a heading that has our name, date, and a description. We always got to indent properly, or we get errors if we don't have the proper indentions, and use meaningful names for your variables. So here's an example. This is somebody else's program, just to show you what they wrote, just to give you ideas. This does not have to be your program. You come up with what you want. So Jim is writing a report about planets, and for fun facts, he wants to calculate the volume and surface area for a planet. He needs your help by providing the name of the planet and its radius. So the planet Earth. So he had an input statement that says, which planet would you like to calculate? And the person, when they ran the program, it popped up the box and they typed Earth. So he prints the planet Earth. That's using whatever they input. And then it says, what is the radius of Earth? So there was an input statement then that popped up a box that said, what is the radius of Earth? So the person entered, when they ran the program, 6371. Now he may have said in kilometers. You can say, what is the radius of Earth in miles? What's the radius of Earth in kilometers? He said kilometers, so they put 6371. And so then the program, that's all it asked for. It asked for the radius and the planet name. Then the program calculated, it has a surface area of, here it is, 509,805,890.96 kilometers squared, and a volume of 1.0826577771 E plus 12 kilometers squared. They put this in scientific notation. That's something Python does all itself. Don't worry about that. Just make sure you have the calculation correct. That you use the correct formula for a sphere. That was, if it's a planet, you use these calculations. 4/3 times 3.14 times the radius cubed. So then you're going to put your code here and you're going to write your program. So let's look at that on the actual template. I'm going to pull the template up here. Oh, and here's the rubric. Here's how you're graded on that. 10 points on program design. That means you've got your comments up there. That's your name, date, and purpose. You've indented properly and used meaningful variable names. You get 10 points for that. You get 40 points if it has all of these elements. You've got the pseudocode, and the pseudocode matches the program you wrote. You had your main function. You imported your math module. You used the math functions to perform exponents and square roots. You had a description of the word problem printed to the screen. You used the input functions, and all your calculations were printed to the screen. Okay, so that's 40 points. 30 points for it runs correctly with no errors and produces what it's supposed to produce. Your calculations are correct. And then 20 points for those questions at the end, the postmortem review. Those questions are worth 20 points. So let's look at this on the template. Here's the template that's in Google Classroom. Looks just like what we're looking at, except this is where you can type in. So let's start our pseudocode together as a class. We'll just start looking at this. All right, so first I put name, date, purpose. I would import. Do we put the pseudocode in idle as a comment or in the Google Docs? No, the pseudocode goes right here in your template. Right here, insert your pseudocode. So I'm starting my pseudocode. Import math module. Define main function. There's my first 3 lines of my pseudocode. That should be the first 3 lines of all of our pseudocodes, because we got to have our name, date, purpose at the beginning of our program. We've got to import the math module, and we can define the main function. But here's where we start having our own choices. Like, let's say, for example, that I wanted to do one like this. So I'm going to print this program will calculate planet surface area volume. All right. Now that's not exactly. I didn't put this in quotes. This is not a Python command. See, I'm not doing that because this is just my plan. That's just my pseudocode. I'm just saying Well, that's what I'm going to print. I'm going to print that this program will calculate surface area volume. User input planet name, user input radius. I'm going to do it in miles. Input in miles. Then I have to calculate surface area, which would be this one. Oh, by the way, I need to fix this template. That's squared. It's not R times 2. I'll fix those. Surface area, which is, make sure I look at the right thing. 4 times 3.14 times radius squared. That's what I will calculate. And then I'll calculate volume, which is 4.0 divided by 3.0 times, I'm using just this formula right here, times 3.14 times radius cubed. Print results in the main function. Did I leave out anything? I create a word problem that calculates volume surface area. I print a description of the word problem at the beginning. So I'll say I'll print that this program chooses to calculate that. I will ask the user to input that. So I got my user inputs. I'm going to use 3.14 for pi. I'm writing the pseudocode, print the results of the calculations. So I just put print results. I would do so. Like that would be pseudocode to do this right here, basically. Except I did it in miles instead of kilometer. You can do it in miles, kilometers, whatever. You do it in inches. If you're doing like a baseball or a basketball, you're asking about a sports ball. So pseudocode. Notice if I put that in Python, it will not run. That's not Python programming. That's not what pseudocode is. This is pseudo means fake. Pseudo means fake. So write whatever you want to calculate, whatever program you want to do, whatever you want to, if you want it to be a ball, if you want it to be a can of some kind, it's, whatever, just write your pseudocode, and then you'll actually go write your program in Python. We would actually go back here and we'd open up our Python window and we'd start writing our program. Start writing our program in our Python window. Checking to see if we have errors from time to time. That's what you got this week, the math module. Take some time on this. Think about how you want to do it. You don't have to be planets. You could do all kinds of things. You just have to use one of those, a sphere, a cone, a cylinder, a cube. And it gave you the calculations in there. But I'll go back into that template and make sure it's squared and cubed, because when you copy that, it loses that. So make sure you're using the right. You might go back to Python to the lesson and it has it correctly to make sure you're using the right formulas. Or you can look up the formula for volume of a cube on the internet. It'll give you the same thing, because that is the actual formulas for that. So, all right. Any questions? If you didn't get last week's program turned in, it's not difficult. You guys can do that. So it was worth 50 points. So get that one done too. If you didn't, most of you got that turned in. I think there's just a few that maybe don't have it in yet. So, all right. If you got questions, I'll be here. Let's see. This is an A-Day Friday, so we have Wednesday and Friday. If your grade's below 70, I'll see you then. Or if you have questions, you can also email me if you have errors in your code, and I'll help you debug the errors. But otherwise, we'll see you guys next time.